Hey guys, Mr. Middleton here, talking about the properties of parallel lines. This is a start of our new chapter. We'll be talking about parallel lines, the angles they create, all that kind of good stuff. And so today we'll look more specifically at the different angle pairs and I guess what's special about them when we have parallel lines. Alright, so before we start, we should probably define a term as transversal. A transversal is a line that intersects two coplanar lines at two distinct points. Okay, so a line that intersects two coplanar point, or a line that intersects two coplanar lines at two distinct points. Distinct points. Okay, if we look at the diagram of this picture, we have like 3 times. This would be a transversal. This is an example. I know sometimes words can be confusing and you don't really know what they're describing, but this is a transversal. You see this line intersects these two coplanar lines at two distinct points, at this point and this point. Okay, so what would not be a transversal, this is what's not a transversal. Okay, not a transversal is an example like this. Okay, you might say, hey, this line intersects two points, or the two lines, but he doesn't intersect it at two distinct points, so this is not a transversal. I'm going to cross this out just in case somebody's listening to me on mute. Okay. Alright. What I'd like for you to do, just to make sure that you're listening to this, and not just pausing it or whatever, silently, and just writing down what I say, is if you could please draw a smiley face in the top left corner of your notes. A smiley face at the top left corner of your notes, and then I'll see that you did that, and then I'll know that you listened to the notes. Okay, great. Alright, so here we go. We're going to talk about the different types of angle pairs that we'll be looking for today. Okay, now transversal happens all the time. A transversal happens whenever a line intersects two coplanar lines at two distinct points, but the relationships that we'll talk about happen only if our lines are parallel. Okay, and so let's just we'll talk about 3 special pairs of angles. Okay, one pair is going to be called alternate interior angles. Alternate interior angles. Okay. One pair will be called same side interior angles. And the third pair is called corresponding angles. Corresponding angles. Okay. Excuse me. Alright, so here we go. Their names kind of tell you where they're going to be. Okay? So our alternate interior angles, alternate, interior. If you think of our 2 lines, our transversal intersects 2 lines. The inside of these 2 lines is here. Okay? Alternate interior angles happen on the alternating sides of the transversal. So, for example, I call this angle 1, angle 2, angle 3, angle 4. Okay. Angle 1 and 4 are alternate interior angles. They're inside, they're on the inside of their two lines, and they're on opposite sides or alternate sides. Okay, so those are alternate interior angles. Angle 2 and 3 are another example of alternate interior angles. Okay? Because again, they're on the inside and they're on opposite sides. Okay? If two parallel lines are cut by a transversal, these are parallel lines. If two parallel lines are cut by a transversal, then alternate interior angles, and I'm going to abbreviate here, alternate interior angles are congruent. I'll write congruent by it this time, but for the rest of the times if I write just that congruent sign, you'll know what that means. Okay? It means they're the same. So angle 1 should be the same as angle 4, and angle 2 should be the same as angle 3. Okay, and we can look at some proofs for that tomorrow. Okay. Same side interior angles. I'm going to number these angles again, same way here. Just call this 1, 2, 3, 4. Okay, and these names aren't supposed to be tricky at all. Okay, same side interior angles. If you think about the interior, these are the interior of these two lines, the transversal intersects, the same side of the line. So one pair would be angle 1 and angle 3. It's the same side interior angle. They're on the same side and on the interior. Another pair of same side interior angles would be angle 2 and angle 4. Okay, same side of the transversal, the right side, and inside of our two parallel lines. Okay. If two parallel lines are cut by a transversal, then the same side interior, and I'm just going to abbreviate it like this, same side interior angles are supplementary. What does that mean? It means they add to 180 degrees, just in case you don't remember that from last chapter. Okay, corresponding angles. I guess this is the hardest of the pair, but they're not too hard to remember. I'm going to label some angles. I'll need more this time to talk about. Okay, all right. So corresponding angles, I kind of think of them as being in the corresponding parts or in the like same spot on the different lines. Okay, so here's how I think of it. I'll give you a pair of corresponding angles because there's a lot of them. A pair of corresponding angles. Angle 1 and angle 5 are corresponding angles. Looking at the transversal and the two lines that intersect, angle 1 is the top left angle that's made by the line and the transversal. Okay. Angle 5 is in that same position on the other line. It's the top left of that angle. Another pair of corresponding angles is angle 4 and angle 8. Okay. Another pair would be angle 2 and angle 6. The last pair of corresponding angles would be angle 3 and angle 7. Notice that angle 3 and angle 7 are both the bottom left angle created by the intersection of the transversal in that line. Okay. And so with these corresponding angles, our theorem goes, our theorem goes, if two parallel lines are cut by a transversal, then their corresponding angles are congruent. Corresponding angles are congruent. Okay, so these are the three special types of angles that we should know. Okay, alternate interior angles, same side interior angles, and corresponding angles. And then notice that the same side interior angles are supplementary, same side sup, 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 and the other two are congruent. I just did that because that's how I remember it. Sup. Okay. All right. So take a second, pause it here, and try to do these problems. Okay. Tell me if they're alternate. Well, let me cross that out. Although, excuse me, although alternate exterior angles is something that we can look at, it's not really an angle type that we will pay very much attention to. So you can cross that out. Consecutive exterior, not something that we talk about at all. Okay. And then consecutive interior, and you'll see this on different worksheets, or if you're looking at different resources. Consecutive interior is known as, and we call it same side interior. Okay. So, angle 1, angle 9, looking at that should be corresponding angles. Angle 8 and 13. If you see this as the transversal, these are the two lines that intersect. 8 and 13 are same side interior. Okay. Angle 6 and angle 16. That's nothing. Okay, it has no relationship to us. It's not alternate interior. It's not same side interior. It's not corresponding. Okay, angle 4 and angle 10. I'll just try to do this so that I can see 4 and 10. They're inside the two lines that the transversal intersects. So 4 and 10 are alternate interior. Angle 8 and 16. Okay, looking at this, I'm going to try to give it 8 and 16 here. Bottom left, so I see their corresponding angles. And 10 and 13. Okay, I guess I'll try to darken this up a little bit. 10, 13. Alright, so different kind of angle, but if you look at it, we have two lines and a transversal, a line that intersects both of those lines. So 10 and 13 are actually same side interior angles. Okay, now I want to point this out before I move on to the back side, that even though that these angles are these corresponding same side alternate interior angles, make sure that you notice the difference between this diagram at the bottom and these diagrams that we use for our theorems up top. Okay. In our theorems up top, we always said two parallel lines. If two parallel lines are cut by a transversal. Down here, notice that these two lines are not parallel. Okay, they obviously will touch at some point. Okay, so even though for A, angles 1 and 9 are corresponding angles, they won't be equal. They would only be equal if our transversal was intersecting parallel lines. Okay, but that doesn't change that they're corresponding angles. It just changes that the corresponding angles aren't equal. Okay, flip to that. Let's put some numbers to these problems. That usually helps kind of solidify the things that we're talking about. First question says if x equals 115, is it possible for y to equal 115? Okay, so I'm going to put 115 here. And we're talking about new information, but this is what I kind of like about geometry, is that you never really forget what you just talked about. You always have to use it. So if x is 115, is it possible for y to be 115? Well, what do we know? Okay, x should be 115. These are alternate interior angles, and these two lines are parallel. Remember, you can tell if two lines are parallel. I guess I got to tell you this for the first time. Two lines are parallel because they drew these arrows here. These arrows indicate that those two lines have the same course. Okay. Okay. So So these two lines are parallel, their alternate interior angles are congruent, great. Can y be 115? The answer is no. What will y be? Well, x and y together, if we're just looking at what we talked about last chapter, x and y together are a linear pair. They make up a straight line. So we know that x and y are supplementary. It's going to abbreviate and say are sup. Okay. Okay, so that means y would equal 65. Okay, from just our notes today, we should see that 115 and y are supplementary because they're same side interior angles with parallel lines. Okay, so then again y should be 65. So no, it wouldn't be possible. Okay, now in this next section we're going to look at some problems that would probably most likely be on a quiz or a homework assignment, something like that. And we're going to look to solving them. So we got to look at the relationship that's made and then see what we can do with it. So for one, two parallel lines, a transversal. What kind of angles are these? They're inside the two parallel lines. They're on different sides or alternate sides of the transversal, so they're alternate interior angles. What do we know about alternate interior angles in parallel lines? Well, they should be congruent. Okay, so we know that 2x equals 80. That means x is 40. Okay. Number two, what kind of angles are these? Two parallel lines and a transversal. These two angles are corresponding angles, right? You see that they're like the top right of the intersections of both of those. We know corresponding angles are congruent. So 120 should equal 3x. Divide by 3. X should be 40. Number three, what kind of angles are these? Well, they're inside of our two parallel lines. They're on the same side of our transversal. So they're same side interior angles. Same side interior angles add to 180. So 2x plus 110 should equal 180. Subtract 110 from both sides. 2x should equal 70. Divide by 2. X should equal 35. Okay? Going through those kind of simpler problems, if you want to pause and see if you can get these answers before I go to them and kind of fast forward until you see them, you can do that. If you want to just keep following me, you can do that as well. Alright, so here they kind of add some difficulty here because they're giving us a different variable. I want to find x, I guess, and y. So for 4, a couple things we see. We should see that these two are vertical angles, but we can't use that yet because, well, we have y and x. From today, we can see that these two are same side interior angles. They should add up to 180. So I'm going to say 75 plus 5x minus 10 equals 180. So that's 65. 5x plus 65 equals 180. Subtract 65 from both sides. 5x equals 115. Divide by 5, x equals 23. Right on that. Okay, I'll double check to make sure what I did was right. It's 115 minus 10, which is 105. Good. So 105 plus 75 is 180. Great. And I can use that to find y, because I know that these two angles should be the same. So 105 should equal 10y minus 25, or 130 equals 10y, which will make y equal 13. And I'll just plug this in just to see. That should be 130 minus 25, which is 105. Great. Because vertical angles should be congruent, I know that that works out. Okay. Same thing here for number 5. We got two parallel lines and a transversal. And so this is 60, this is 60. I know that that has to be 60 because they're alternate interior angles. 3x plus 15 equals 60. Solve it. 3x will equal 45. X equals 15. Okay. looking at these two angles here to find y. So this is 3x plus 15. These two lines are parallel. We have a transversal. They're corresponding. So if I know that this angle then has to be 60, I can say, well, 60 equals negative 5y minus 10. So 70 equals negative 5y. That means y has to equal negative 12. So x is 15, y is negative 12. Okay, here, this is kind of tricky, but I like problems like this, especially in this section and chapter. Because you need to find x, but it doesn't really have a relationship with 102. But look, if this angle is 2x minus 12, where else can we put 2x minus 12? There's two places I can think about. Two places I can think of. I can either use it as a corresponding angle and put it here, because I know that these two angles should be the same. Or I could use it as an alternate interior angle and put it here. Either way, you should see that 102 and that congruent angle should equal 180. So I'm going to just put it here just so we can see it. 2x plus 12. Okay, alternate interior angles, so they're congruent. So I know that 102 plus 2x plus 12 should equal 180 because they're a linear pair. Okay, and then I will 114, is that what I get? So 2x plus 114 equals 180. 2x then will equal 66. Am I right on that? I think so. And so x will equal 33. Okay. Find the bottom three. We'll check it in class. And I guess I'll use this to help you out. Some extra practice in class tomorrow. Alright, show me those notes. And see you tomorrow.